Make sure it's working good. Hello, computators on YouTube. Thanks for joining me today on this live stream. This is my first one, so I'm just getting started here. So let me make sure it's working. Okay. I'll send out a chat message. All right. So I want to show you some exciting things today. But let me introduce myself. My name is Christopher Tate, and I am a Red Hat principal software engineer, and I'm in the Red Hat research team, which means I get to work with really cool technology that's bleeding edge, and I get to work with universities because we do research and development. I get to help with the development. The university professors and graduate students get to do the research, and we work together on projects in a shared research cloud environment. And that's called the New England Research Cloud. So I've been an open source developer for many years. I've been a software consultant and helped many banks with solutions like self-filling infrastructure and event-driven automation. And today I want to show you how to use all the great open source tools so that you can deploy your applications and microservices to the cloud to solve your own problems and bring your applications to life. I'm going to give you an example of what we've been able to do with the Smart Village platform and how we've been able to deploy that onto Red Hat OpenShift and also be able to develop the code for it in the same Red Hat OpenShift environment locally on my own computer. So let me share with you a little presentation more about this. Here we go. So the Smart FIWARE Smart Village platform is brought to you by 3 different organizations. I come from Red Hat, and I'm the software engineer there, plus Boston University, who is the student research that's going on for smart traffic lights and smart villages. We work with a professor and their graduate student on this project. We work together all the time. We build microservices and data science and deploy it to the cloud. Smart FIWARE, or Smart FIWARE, is a Swedish company, and the owner of that is in a little village called Veberad, Sweden, and they do a ton of smart village technology in their town. And we partner together because they want to promote open source software and on the right platform, which is Red Hat Enterprise software. And I'll show you why. So that's the partnership. The team, like I was saying, Yingqing, she's the student at Boston University. She developed a Python microservice using open source tools to simulate traffic on actual roads. And we've built that into a microservice as part of our platform. Jan Malmgren is the founder of Smart FIWARE in the village of Veberad, and myself, Christopher Tate. So in the beginning, Jan reached out to Red Hat wanting to see what there is for driving open source for digital twins, like his city. or his village. It's a digital twin. He has 3D models and buses and all kinds of technology going into his village that makes people in the village happier. They've been able to bring lights into places that are efficient, that in public places where they wanted more visibility when people are walking by, and better water, and all kinds of exciting technology like that. So Jim reached out to Hugh Brock at Red Hat Research and the Red Hat Collaboratory with Boston University to see if we can do a project together. And Jim worked with the Boston University professor Christos Cassandras to submit an application for funding with the Red Hat Collaboratory with Boston University. And our project received a 2023 Red Hat Collaboratory Research Incubation Award renewal. And so we've been able to work for 2.5 years, or we've been working together for the past 2 years, and it's been a really exciting project. So this project all started with the Red Hat Social Innovation Program. I became the architect of the Red Hat Social Innovation Program to help bring cool projects to life that help Red Hatters like me contribute to socially impactful projects that are really cool. And so this was one of those projects that got started with the Social Innovation Program. Now, what do we provide the Smart Village platform? We have open APIs for smart cities. So this is an example of our open APIs for tracking data on IoT nodes and tracking bicycles, the state of smart traffic lights. Traffic flow observed means cameras that can count the number of people at a particular spot on the sidewalk. It's not trying to identify people, but just count them. And other traffic lights, people, and simulating traffic, because that's what we do. We don't have a smart traffic light in place in the village of Eberod yet, but we are simulating it and reporting on that simulation. So that's one of the APIs. We're tracking time and vehicles and results on the map. So that's an idea of what our open APIs are about. And I want to help you get started building APIs like this so that you can start playing with IoT edge type technology and the APIs that bring that to life that are supported and based on standards. That's what this is about. So we gather data from external services, these IoT nodes, for example, in the village of Eberod, and we interact with open source projects for simulating traffic, like the Sumo simulation. Sumo is a traffic simulator software that's open source. And this is the microservice built by our student at Boston University. And she put this code together that does traffic simulation. It's really cool. So we help university students study these smart indicators with our simulation reports. For example, here's a simulation report that I ran with input parameters for average vehicle traffic south to north or west to east, and a whole bunch of parameters and graphs to see if changing certain parameters causes the performance of the traffic light or the waiting time of people and vehicles to decrease. That's the goal. That's what we're trying to study here. So that's an example of what we're working on. Now, every website deserves the best in security, in high availability, and you can see our pods running here, scalability, being able to scale these pods together, like 3 pods running the same application or more to improve performance. Updates. Now this is Red Hat OpenShift that I'm showing you here. This is our New England Research Cloud. And the cool thing about OpenShift is that it can automatically apply security updates to your images so that you're always up to date with the right security in your pods running, and powerful storage options. So here's a bunch of persistent volume claims that store data in search engines and cluster managers and databases. So you can take a look at our New England Research Cloud environment in production. That's what we're doing here. And for more information, you can check out nerc.mghpcc.org, and you'll learn all about our New England Research Cloud. Now, here's another view at our services running here. There's a bunch of them, and they look pretty happy. So how do our microservices communicate? There's PostgreSQL, the open source relational database of choice for me, and Apache Zookeeper cluster management, Apache Solr search engine, which is the foundation of our REST API for querying very fast records, and the Smarta by our Smart Village REST API. So we built our own API to be able to serve up data with role-based access control. We have the Red Hat Vertex Event Bus. You might be familiar with Quarkus or Vertex, and it's asynchronous reactive technology that is really powerful so that you never block the event bus. And when you query a database, it doesn't block the thread. That's the power behind it. And you always get either a completed result or a failure that can be handled. So that's the idea behind reactive services. And Strimzy, Kafka, topics, that's another part for messaging. So we have many open source communities with this project, including GitHub. You can find our software at github.com/computate-org/smarta by our Smart Village, and Quay.io, where we have our container images for all of this, hosted at Quay.io/organization/computate.org, and Maven Central. You'll find all the dependencies and the software for the Smart Village project itself. And we have a mailing list, and we're on YouTube. So now I'm going to talk about the real world data. We pull in real world data from IoT nodes, and we have a demo of the traffic simulation, which, let's check if this is still working. I haven't tried this out in a long time, but we can try it. Let's see. I'm going to show 500 objects at a time on the map, and we'll pivot on map location and zoom in on this intersection here. I'll pull up stats for time in seconds, and we'll change this speed in seconds to be 0.5 and animate. So let's see if this is working. Yep. So here you can see that we have a person walking down the sidewalk here in purple, and we have vehicles that are approaching the intersection. So what happens is these vehicles should queue up on the left here, and these vehicles on this road will pass through the intersection. So you can see that yellow dot passing through, and eventually the traffic light will turn from green to red. Let's wait for it. You'll see pedestrians also crossing the street in that direction, but now the light just turned from green to red, and now cars are flowing from this direction. So they're going to cross southeast, and so this vehicle was able to pass while these vehicles are getting queued up. It's the same for pedestrians. Now the traffic light stopped, and here cars are passing in this direction. So you can see how this type of traffic simulation is very useful. You can improve your algorithm by following, well, by using data science like we're doing here to improve traffic conditions. So these people are crossing. So I hope that gives you an idea of what we're doing with traffic simulation. So let me continue here. Right, so the graphs in our simulation are something that we're working on. So this, we can rerun this report here, and this is going to recalculate our traffic conditions. So the report is progressing. It needs to get to a certain point before it can show the graph. So now we have one iteration calculated. We'll get another one soon. Now we have 2 iterations, and we're seeing the performance improve here. We want the average waiting time of vehicles and pedestrians to go down. Running, running, running. Now we're at 4 iterations. We're at 58% complete. Continuing to run. Seven iterations. Is it going to do 8 iterations? Let's see. There we go. And now it's completed. So pretty fun to watch how we can improve traffic conditions over time through calculations like this. What else is happening? We are working on mapping things out, although I haven't deployed that part. So that'll be, I'll show you some more in the future. But we're working on testing traffic conditions. No, so what I want you to understand is that there are standards for edge device computing here. When I talk about traffic flow observed and crowd flow observed cameras that are counting people on sidewalks or vehicles in lanes of traffic, there are standards for all that. So let me show you what I mean. Localhost. Let me start up the Smart Village application locally here. I'm going to run this in my IDE Eclipse and show you here the latest development of these edge standards for traffic flow observed and crowd flow observed data. So it looks like the site's running, and I'm going to refresh the page and get to the site and pull up. We're going to pull up traffic flow observed. So here you can see that we have 2 lanes of traffic that we are tracking right now. This direction, and you saw cars flowing this direction in our simulation. And this direction, cars flowing this direction. So we're monitoring how many cars are in this lane, or both of these lanes. Now, we also want to see what pedestrians are around, so we can pull up crowd flow observed. And you'll see here some polygons that represent the places on the sidewalk to watch for pedestrians. So here on this corner, here on this corner, and this corner. We can keep track of all this data through standards. So these are the 4 intersections, and I can click on one of these and pull up the data. We follow standards like GeoJSON. It's a JSON format for storing polygon shapes. And here's the coordinates for that data in latitude and longitude, a whole bunch of different points. And it's the same for traffic flow observed. This one has even more data. It's more interesting. Let's see, I need to go to, I specified the wrong ID. So let's go to this one, for example. And so this one is a different type of GeoJSON called line string, but it also has coordinates. And you can see how we're able to curve the lane of traffic according to the road here and keep track of that data. And we want to keep track of the average vehicle speed on that lane and a few other details, the gap distance, vehicle length. So that's an example. So this is kind of a presentation that I did in the past, so it's got a few extra slides. Now, I want to show you how to start building this own technology yourself. Are you interested in developing smart city technology and edge technology, IoT, sensor data? That's what I'm here to help you with. So let's talk about how to get started developing your own edge IoT-based applications. And I made some documentation, so it's in github.com/computate-org/smart-village-operator. Now, I haven't introduced you to the Smart Village Operator, but it's basically an OpenShift way of automating the install of platforms, services, microservices, everything. You can automate all kinds of things, and that's what we're doing here. So I want to share with you, I need to put a link to this documentation, but it's in Docs, Overlays, Sandbox. I want to show you how to become a Red Hat developer for free and get started with your own developer sandbox for free to start playing with this kind of technology in the cloud. Let's get started at developers.redhat.com. So you'll want to log in, click login. Here's where you can register for a Red Hat account if you don't already have one. You can register. So you can choose a username and password, and keep in mind that the Red Hat developer subscription is for individuals. Are you an open source software developer trying to develop your code? Well, you can follow this Red Hat developer subscription to get started for free, but just keep in mind that this isn't for doing work for your own company. This is for you as an individual. I'm trying to empower you as an individual to get started with open source software. If you've never played with it before, it's really fun. There's so much out there, so much to learn, and it's always changing. So I love that type of thing. So read through the developer subscription, and see if it's right for you. And if you agreed to the terms, you can get started for free and create your account. So once you're a Red Hat developer, you can start a developer sandbox. And this is what I want to show you. Developer sandbox. I'm going to start a sandbox for free. I'm going to sign in with my Red Hat account, although this isn't my Red Hat employee account. This is a separate account because I like to have both. Okay. So it says your account is waiting for approval. This may take a few moments. You are ready to get started. Wow, that was so fast. So I'm going to start my sandbox. Okay, now I click on Dev Sandbox. And let's see what happens. Welcome to the developer perspective. How exciting. Should we take a tour? Okay, perspective switcher. Switch between the developer and administrator perspectives. My favorite is the administrator perspective, but I guess I'm very used to OpenShift. So you might find the developer perspective more friendly, but it doesn't actually have to do anything with you being an admin or you being not an admin. It's just a different view of your project. Okay, let's go next. Monitor applications and metrics, create custom metrics queries. Okay, we can do metrics. That's cool. That's like the performance of your application. You can see performance information. Search for resources. Yeah, we can search for resources. We can use the web terminal. You know what? I don't think I've ever used that, but that is cool. We might try that for the first time. And help is always good. User preferences. I guess I've never checked out the user preferences. Now we're ready to go. User preferences. Oh, okay. You can choose your perspective. Definitely want dark theme. Administrator. Project. So it gave me a project named computate/dev because my username is computate. It just appended -dev to it. Okay. Topology, I'm not worried about that. Okay, that's interesting. Let's go to the administrator perspective. Now, I'm going to follow my own documentation here and try to help you out. with getting started with your own developer sandbox, let me just move this tab over here. Okay. So we have an account. We can download the OC command, the OpenShift console command. That's an important step. So let's do that here. Oh, you know what? I wanted that to be there, and I wanted this to be over there. So I'm going to move that over there. I'm going to close all my other tabs. All right, now I think we're good to go. So we want to be able to run commands in our OpenShift console from our terminal because it's really powerful. And so we will click on this question mark in the OpenShift console, click on command line tools, and you can download it for your operating system. I've seen this work for every operating system from Linux, Mac OS, or Windows. So you should be well supported there. So go ahead and download the right version for your operating system. And you open up this archive and you can extract it somewhere. Where did it go? For me, it's over here. So you need to extract this. And on Linux, for me, the best place is somewhere in your path. So if you're on Linux, you can type echo $path in uppercase letters, and it'll show you what your path is. And my favorite place on the path to put things is home Tate /home/myuser/bin right here. This is where I recommend, but you might not have that depending on your flavor of Linux. So keep that in mind. If you're on Windows, you can do echo %path and it'll show you your path. You may have to open up the environment variables program and configure your system environment variables to include a new directory where you want to put your OC command. That's a little advanced, but hopefully you can figure that out on Windows. If you're on Mac OS, I think it's about the same as Linux. Just find a place in your path to put the OC binary, and then you can run commands. Let's go back and log in to the terminal here. So let's see here. Where is the link? I'm going to refresh. So there's a copy login command. And so you want to get your token here, and you can copy it to the clipboard and paste it in your terminal. So that's an example. Now you should be ready to go. So if I do OC project, then it will tell me that I'm using Computate Dev on the server, and that's my project. Very exciting. I want to actually test out this command, OpenShift command line. Let's try that. Initialize terminal. Start. Okay. So I can type OC project and it tells me the same thing. User project computate dev. Very cool. So we can do this in the terminal. Now, something that will help you with your deployment, well, it's going to help us use the Smart Village operator to be able to deploy some new components very easily without having you install a bunch of dependencies on your own operating system. So let me show you what I mean. We're gonna run this OC create role binding to create a default edit cluster role binding to the service account of our project. So this is kind of fancy because it's got a command inside of a command. If I type this here, just the inner part, let's see what it says. It says computate dev. So that's my project name. And we're gonna update the role bindings for this default service account. So if I do OC get SA/default, then you see default here. Sorry about my dog. Now I'm going to run this command all together. OC create role binding. And now we've got that role binding created. So we're good to go. The default service account will be able to edit things in our namespace, in our project. Now, I want to try to debug a container, which means start a container in your terminal that's running within our OpenShift project inside the cluster. So let's see if this works. OC debug image quay.io /computate.org/smartvillage-operator. It says it's starting. And it looks like we're in. So let's see here. This is all the stuff in our Smart Village operator. This is so easy to do. Okay. So something that I want to do here is load the namespace into an environment variable. The namespace is also the same as our project. For me, it's computate dev. So I'm going to run this command, and then I should be able to echo $OpenShift namespace, and it outputs computate-dev. Pretty cool, huh? Okay, let's try to install our first application in our developer sandbox. I'm so excited to try this out. So I wrote an operator which automates a whole bunch of steps for you. And the language that I chose is Ansible, because Ansible is the language for automation in the open source world. So let's try this out. It's going to run an Ansible playbook called apply edge mongodb.yaml. And it's going to call the MongoDB, and it's going to install it in our namespace, and it's going to configure it based on this configuration here. So let's paste this in and see it run. Oh, has no attribute namespace. So this is why it's a hackathon, because sometimes we don't get things quite right yet. So let's see here. Okay. I'm going to skip out that one for a sec and see if this one works. Let's just see if this installs the Ryan LD context broker and if our MongoDB one is having a problem. This looks like it's applying. So I think we got some work to do on the MongoDB container. Okay, so this one ran a little better, but it depends on MongoDB, so it eventually failed because it wasn't able to create a MongoDB user. So we need to get our MongoDB playbook working, and probably need to look at the code for this. So let's pull up this playbook and I'll show you inside since we're troubleshooting right now. Okay. So this said that line 12, it's running set name and namespace vars. So let's see here. Set name and namespace vars. Metadata name. And metadata namespace, CRD complete. Okay. So what we can do is debug this live. What I want to do is vim apply edge MongoDB. Oh, we don't have vim. Let's try BI. Okay, that works. That's good enough for me. I'm going to add a debug statement in Ansible. Var is CRD complete, because right above we created this CRD complete var and loaded it with data. Now we just need to run this and see what it has inside. So it's got a name, but no namespace. So that could be the problem. And I forget. That's probably not the right thing to do. Let's look at another playbook for Orion LD because that was working better. Apply Orion LD context broker. That one has, okay, what, let me think. We already have these we already have these variables set here. So we don't need them set here. I think that's the problem. Although I'll have to think about that more. But let me go back to here. And I'm just going to remove these lines for now. Why is that in there twice? Wait a minute. Okay, let's try running this again. See if it's happier now. Apply edge MongoDB. Okay, that ran. So let's take a look at our workloads, pods. I'll open that in a new tab and see if we have a MongoDB pod running. Look at that. We have our debug container that we're running in the other tab. We have MongoDB, it's running, and 2 of its readiness checks passed. And I think this one is for, I don't know. But we have MongoDB running. Let's try running. Yeah, the Orion LD context broker now. So we're going to paste this in and run this. Let's see if it gets further. Yeah, it completed. That is a good sign. Let's look at our pods. Container creating, it's creating Orion LD. So you can open up these pods and you can check the logs and see if everything's okay with the logs. You can check the metrics and see if CPU and memory is according to your design. You can check the events and you can see these events are all happy. If they were unhappy, they would be red. And I spend a lot of time looking at the events to see if there's errors, service account problems, or storage problems, or a whole bunch of other problems, readiness check problems. Lots of things can happen. We have our Orion LD pod that connects to MongoDB. Let's see how it's doing. Check the logs. It does have an error in the log, but I think that one is okay. We check the details. Oh, it looks like it's ready now. We check the events. It all looks good. Let's go back to pods. So Orion LD is now running. Yay. Okay, I'm not going to cover RabbitMQ and IoT agent in this demo today because I learned that the RabbitMQ container provided by Bitnami does not support the MQTT protocol version 5 needed to be able to do some of the stuff that we want to do for IoT agents. Although I think we could use AMQP. But I think this would be better for a future live stream. Maybe I should check if there's any questions in the chat at this point. This is my first live stream, so I'm not very familiar yet, but is anybody here with a question? I'll just put that out there. Now, here we successfully started a brand new Red Hat OpenShift environment. It creates a project within the Sandbox. Okay, so it's a developer sandbox, and the technology behind it is Red Hat OpenShift. And we ran an operator. We deployed some, let's show you what we deployed today. we deployed 2 deployments, MongoDB and MongoDB Orion. I don't think we need both of these, but I'm gonna have to review to make sure I'm not crazy. But I think we just need one of these. But we got 2 MongoDBs, and we got an Orion LD context broker deployed. So this is our deployments, and if you want to take a look at the deployment, you can check out the environment variables, and here are the environment variables. It runs on port 1026. Now this deployment it should be linked as well to a service. And a service is like an internal fully qualified domain name to access the service within your project. So check this out. If I go to this service, it gives me the host name for this, and the port is 1026. So remember that. We're going to go back to our terminal here and curl this address colon 1026, and we get a response back, which is pretty cool. Let me remember Orion LD 1026. I forget. Orion LD / v2 entities. Yeah, let's try an address like that. So we go here, we do Orion LD, we paste the domain name that we got from the services page, colon 1026 / v2 / entities, and we get an empty array back. Hey, isn't that cool? So this is working. Now let's see what else we have here. We have networking, routes. Let's see if we created a route. Yeah, in fact, we have a route directly to our Orion LD sandbox. So if I go here, you can see 400 bad requests. I can add /v2 entities, and you have a working API that you can start playing with to send smart device data straight to your app and start playing with this. There's a lot more to know about the Orion LD context broker and smart data models and all the standards around that, which is definitely a subject for another day. But if you follow along with these instructions, you should be able to do this yourself. And I will be so proud of you getting your own sandbox environment running with a context broker. You might not know what that means, but it means a lot. It's really powerful stuff when you're talking about Internet of Things, edge technology. This is a big standard that's got a lot of traction right now. So it's really fun stuff. I hope you've learned something from this today. What else can I show you? I can show you the storage that's been set up. So persistent volume claims. We have 2 different persistent volume claims for 2 different MongoDBs. That's something that I need to work on because that's very redundant. And what else is in here? Oh, let's take a look at our quota. So it's going to give us a resource quota. Let's see, for computate deployments, there's a whole bunch of resource quotas here. Computate deploy. So what does it say here? It says you're limited to 20 CPUs. Wow, that's generous. 14 gigs of RAM. Oh, wow, that's amazing. So definitely take advantage of this sandbox environment. It's got a ton of resources. You can deploy a lot of cool stuff here. That is so cool. Um, what else can I show you? What else have we used today? Workloads, stateful sets. We don't have any stateful sets. It creates secrets. So there's a MongoDB secret that has the credentials for the root password. Orion LD has its secrets to connect to the MongoDB. And what else? Bunch of automatically generated stuff. These are the important ones that you might want to know about: Orion LD and MongoDB. And probably also create some config maps. Yeah. MongoDB creates some stuff. Orion LD creates some stuff. Curious what that is. It's got some stuff. Cool. Well, I think we're about to wrap up here. I think I'm going to call it a day, but please stay tuned for future webinars. I want to start doing these locally too. I live in Utah, so if you're in Utah, you might be able to stop in and see me at the Bountiful Rec Center in the future, but I'm still working that out. But I hope this is helpful. I've created a lot of YouTube videos in the past, and I want to start cranking those out again and teaching you all the good things about smart device technology standards and enterprise open source standards provided by Red Hat. The services provided by Red Hat are just incredible. As a Red Hat OpenShift or open source developer, I showed you the Red Hat developer program today. Definitely go check that out and become a Red Hat developer if that sounds good to you, and get started with all these cool tools like the OpenShift Sandbox. It's just incredible what they have to offer as an open source developer like me. I love it, and I'm excited to show you more. So thanks for tuning in today. I'm going to end now. Have a great day. Have a great week.